mainly we talk here that the hydrogen, due to the hydrogen bond making, the boiling point of alcohol is higher. And hydrogen bond can make between hydrogen and electronegative three atoms, mainly oxygen, nitrogen, and fluorine. Only, I mean, actually these three, because they are highly electronegative. They can share unequal electron and lone pair, and with the partial negative charge, that make them the possible to make the strong bond between hydrogen and oxygen, or hydrogen and nitrogen, or hydrogen and fluoride. And because of this strong hydrogen bond, this is more energy need to break, and that's why the boiling point is high. Also, we have learned here that as long as the alkyl chain is increasing, the solubility is decreasing, because alkyl are non-polar portion. That means they are not hydrophilic, they are hydrophobic. They actually repel water, not attract water. Okay, so I hope you got it. So if you look into now here the chart, see, this is the hydrophobic region. I just said with increasing the chain. And if you look into the solubility of alcohol, you can see that, see, the tart butyl, the first four alcohol, they are miscible in water, as long as now the if I mean alkyl length is increasing, the solubility is decreasing, because this is the hydrophobic region or the water repelling region, not water attracting repel. That's why. Acidity of alcohol. Actually, we use Ka and pKa. K is the acid dissociation constant, or the strength of acid, and pKa is the log value of Ka. Okay, remember, pK is the log value of uh, Ka value. When log value of K is called the pKa, and this value are inverse. So if you see that um, Ka value is higher, you will see the pK value is lower. But actually, they both explain the acidity of different group of compound. So acidity pKa range, this is the alcohol pKa range, close to water. Acidity decreases as substitution of alkyl group increases. So here, high branching alcohol, that means their acidity is also lower. Halogen and other electron withdrawing groups increase the acidity. So that means this kind of electronegative or nucleophile can increase their acidity. Phenol is 100 times more, 100 million times more acidic than cyclohexanol. So phenol, you know that there is a phenyl group and then OH. But cyclohexanol is kind of cyclic, the cyclic alkane, and then you have the OH. However, due to the alkyl length, this is lower acidic than the phenol. So now, if we look into the structure and K and pK value, we can compare the acidity. If we look into the hydrochloric acid, the pK value, and if you look into the acetic acid, we know the water is almost neutral, close to neutral. If you analyze the laboratory water or some tap water, you may find little bit of basicity or acidity. pH can be little changed, but the pure water, we know that this is the almost a neutral situation, correct? However, here is our Ka and pKa list. So you can look into, we know the hydrochloric acid, very strong acid. So you can look into the acid dissociation constant value and comparatively acidity value. Formation of alkoxide ions. Alkoxide ion, this is like RO. Alkoxide ion, RO. So you remember we also talked alkoxide ion in the alkene chapter. I think so, yeah. So ethanol actually react with sodium metal to form sodium ethoxide, a strong base commonly used for elimination reaction. So more alcohol, hindered alcohol, like more branching, like 2-propanol or butanol, react faster with potassium than sodium. So here we have some characteristics. Like in that case, you can see that not only sodium, but potassium also can react and form the alkoxide ions, and in that case potassium work faster if you have the alcohol like propanol or butanol than the sodium. But sodium metal, when we use, they actually sodium metal is a positive charge, correct? So they actually eliminate the hydrogen, and they take this place. So they replace the hydrogen and they take this place because the strength of sodium here is metal is higher. So this is how the sodium ethoxide form, and here sodium act as a proton like hydrogen ion, and they remove the hydrogen gas. Here we have the phenol, and you can see that how the phenoxide ion can form in a basic situation. You could see the sodium hydroxide, where because this oxygen is highly electronegative, so they are taking the electron and this excess lone pair electron as a nucleophile, so they can take this hydrogen and this sodium can go here. So this is how this kind of alkoxide, I mean if this is phenol group phenoxide, if this is ethyl ethoxide, but all are actually the example of formation of alkoxide ion or group. The aromatic alcohol phenol is more acidic than aliphatic alcohol due to the ability. Yes, here I want to take you something. You remember the resonance. Resonance means actually, what is the resonance means? The delocalization of charge or bond within the neighbor or adjacent carbon atom. Okay, so in that case, this you can see the double bond and the carbon like here and here. But if we want, we can delocalize, replace, change from here to here, here to here, or like that. And this is the one of the reason that aromatic rings to delocalize the negative charge. I mean, resonance is not only about the charge, but I'm talking about the overall resonance. So we can change the charge and also the delocalize the bond. Two are related, correct? So ability of aromatic ring to delocalize the negative charge of the oxygen within the carbon atom, and this is the reason that the acidity is high. So if we have, we can delocalize, and as a result we can relocate. But actually this is legal. There are some element, actually today I took some, I will give you some link to learn the resonance, because since you guys are learning the mechanism, so if you have a clear understanding about the resonance and delocalization of electron, it will be more favorable when you write the mechanism of a reaction. So I will give you the link. I have the detailed lecture on this chapter, resonance and formal charge. If you have a clear idea about resonance and formal charge, your time will be saving when you will review. I will give you after today's class. Yeah, so this is the reason the acidity of aromatic alcohol is higher than the, see here, oh, by the way, here we have some, as I said. So when, if you look into here, how the lone pair, I mean negative charge is transferring the location. It is possible. It was carbon oxygen here, but how, see, look into here. It's coming from here to here attacking. That's why this bond can be transferred to this electron can was there, but it can be transferred here, then it can become here. We can be relocate the things, negative charge. And this is the reason the lots of acidity, the acid properties, they belong, and this is possible. This is called the resonance, so delocalization of charge and bonding. Okay, I will give you the link. I think that will be helping you here to understand. And it's legal, it's possible, it's officially possible. So alcohols can be synthesized by the nucleophilic substitution, usually SN2 of alkyl halide. Here I will say that I wanted to draw some. We have already done in the alkene chapter. Okay, alkene and alkane chapter. See here the page number. So please look into, I think just last lecture and before that lecture we did it. Now I don't have my books. So I could not draw it right now, but go back to this book you have online. Even if you just log into the mastering, you will find the free text ebook, the ninth edition, and you will find, you already explained in the last class. So just look into there. Now we are going to study very famous reagent in the chemistry life, and the scientist who discovered, he got the Nobel Prize for this discovery. And after this reagent discovery, we are enjoying lots of new product in the commercial and the laboratory. This is called the Greek nard reagent. Now we are going to talk. So Greek not reagent, actually we write like that, but I mean metal, and yeah, metal and halide. Okay, we are going to talk here. Yes, this is the general formula of Greek nut reagent, but let's start from the introduction. So carbon, we know the carbon is negatively charged, and we know the magnesium or metal or lithium is positively charged. In that case, so it is bonded to metal, usually magnesium or lithium, and it will attract partially positive carbon. Why partially positive? Carbon is a little bit of debating compound. Carbon is a non-metal, but some places you will find carbon in a group of metallite. Metallite that means that it has little semiconductor activities. But anyway, here we will talk differently, that um, when we will have a metal and the carbon, since we know the carbon is negative and magnesium is positive, that they are bonding. However, it attack partially positive carbon, and this is the carbonyl, good for forming carbon-carbon bond. So we will talk it a little more here. The terminal alkynes can be converted to sodium acetylide by treatment with an unusually strong base like sodium. We can see here, this is the terminal alkyl. We will talk the here we just introduced. I don't know why they put this slide here. Actually this slide is supposed to go after the Greek nut, but anyway, let's check it out here. So terminal alkyne, when react with the sodamide, then what happened? Then here the sodium is the positive charge and hydrogen positive, and this carbon is negative charge. So sodium replace here hydrogen, and they go here, and they form these sodium acetylide compounds and ammonia. So this is the kind of converted, that's this is sodamide is, yeah, very strong base, and this sodium acetylides are useful nucleophiles reacting with alkyl halide and carbonyl compounds to form new carbon-carbon bonds. So we can do this first step reaction, and this is working as a nucleophile. We know the nucleophile means which have a available electron to donate, who looking for the electron or electrophilic, correct? So then these are react with the alkyl halide, and they can make the this alkyl halide. So this is the negative ion, so this bond will be breaking and they will be attached here. They will become here, see, substituted substitution. So reaction alkyne will be formed, and ultimately what will happen, they will, that even you see the alkyne, so ultimately this will form the ketone, aldehyde, and finally the still if you hydrolysis or the acid comparalyze H3O, they will provide the alcohol. So that means if we need some something compound that related to terminal alkyl, or we need the some alcohol related like acetylenic alcohol, triple bond containing alcohol. In that case, we can first do the react with sodamide, and we can make the sodium acetanilide, and then it react with the alkyl halide, the substituted alkyne plus, and then this kind of product. Even if you see here, I want to show you that it depends on if you have alkyl halide, they will produce this kind of alkyne. But if it react with the ketone or aldehyde, they will produce the alkoxide and finally the alcohol. Even sometimes if it is more further reaction, even the secondary tertiary, they can even form the carboxylic acid. We will see the example. Now talk about the Grignard reagent. Grignard reagent formula here is the RMGX. So alkyl magnesium halide, but actually mainly the chlorine and chlorine, bromine, iodine work, but fluoride generally don't work. So this is, please remember. We say the halide work, but actually fluoride not work. Okay, so fluoride don't work, but the chlorine, bromine, iodide work. And this actually we use the ether here. Here we use the ether as a how to say, some to stabilize or activate this reagent. This ether is anhydrous, and we normally talk that this Grignard reagent like single molecule, but normally when they stay and work, couple of alkyl halide molecule stay like together, group like that. So we will see that. So the formula, this one is called the Grignard reagent, and this alkyl, and they share the partial positive and partial negative, positive and negative charge due to uncle distribution of electron. Now, ether are used as solvent to stabilize this complex, as I said. And then iodides are the most reactive, and in between the chlorine, bromine, iodine, other halogen. But remember, fluorides generally do not work. May be formed from primary, secondary, or tertiary alkyl halide. That means we can produce this Grignard reagent either from primary, secondary, or tertiary. And nowadays, we can commercially buy this Grignard reagent. So this is the formation of Grignard. As we said, that it can be lots of, even it can be the aromatic also. So we can produce the Grignard reagent in the presence of ether, and this ether is anhydrous. So you can see here the reactivity of Grignard reagent, the iodide, bromide, chloride, and then fluoride. So it's almost non-reacting. So this is the methyl magnesium iodide, if we specifically tell this reagent. Organolithium reagent. This is the another one. So we saw when actually the magnesium, this is also actually the metal, correct? So this is very famous and useful. We will be seeing, but another one, let's talk here, the organolithium. Lithium is also metal, correct? So lithium here, the organolithium reagent also reacts the same way as Grignard. Can be produced from alkyl, vinyl, aryl halide, just like Grignard. So you need to be remembered that how the organolithium reagents acts and actually which are react, alkyl, vinyl, and aryl. All are work. So ether is not necessary. A wide variety of solvent can be used. So now you have maybe idea that what is the limitation of Grignard reagent. Normally, Grignard reagent we use ether as a solvent to stabilize these reagents, but in case of lithium, organolithium, ether is not the mandatory or necessary. A different variety of solvent we can be used. So, example of organolithium reagents. If you have any question, you can let me know, okay? I have a pressure to finish the syllabus, so sometimes I forget to ask you, but if you have question, please ask me, okay? Yeah. So here we have 1, 2, 3, 4, N-butyl bromide plus 2 lithium. See, we use here, they use here hexane, so we can use the N-butyl lithium. And the side byproduct, 1 lithium add here, and the 1 lithium come here, the lithium bromide. Similarly, lithium chloride, similarly, lithium bromide. So see the alkyl, vinyl, and also phenyl or aryl, whatever you say. We can produce this kind of, we can provide this type of reagent using even lithium. I mean, not only the Greek night with magnesium and ether. Addition to carbonyl carbon. This is also we have in the here page 478. Actually, some are, I really suggest you to go back to book. That's why I give you the page number. These are really important because if you go to the book, you will see couple of example, and that I suggest you to practice, because those type of example we are going to, this we are going to consider for the exam, because we cannot expect that the same example will come to the exam. By the way, I want to declare something. I forgot it. I received email from our coordinator, Dr. Brown, that the examination question is going to be question selected from the general question poll, and the general question poll will made by the three professors. That means me, Dr. Thomas, and Dr. Brown, because he wants to keep the question similar in all sections. Okay, but I think it's fine, it's okay, because I have seen in the previous, like last semester, the final question I even didn't make a simple one question. So I saw them, my batch students did great. Even the second examination, I most of the question took from the general poll. So for me, I see the more easiest question there. So don't worry about it. It is just to make sure that how the question is going to be. And this is the reason that I try to cover each and all topic we have in the while. I mean, here we have. I normally do not cut. If I do the personally handle all the chapter, maybe I could little bit of add or remove on the basis of my perspective, or what I think. But here I actually 100% follow the syllabus. So just to make sure. And the short quizzes that I will be doing. So yeah, that I will be doing, and not. I mean, this is the similar format that Dr. Brown will be doing his one. Dr. Thomas will be doing his section. Yeah, this is kind of. And I think you already got the common mastering homework for all sections. Yeah. So addition to carbonyl compounds. So now you can see here that how it works. So let's see here. Uh, so when we have the Greek night reagent and partially see the negative and positive charge. So this carbonyl carbon is partially positive here. So electrophilic, and this is the negative, So that's why they attack here. So nucleophile will attack the carbonyl, forming an alkoxide. Okay. So this is here how they form the alkoxide salt. And here the magnesium oxide will be here like that, the salt. Now, the mechanism of this addition. Look into here, it's attacking here, and this bond is breaking, and oxygen is highly electronegative. So unequal electron distribution, as a result, we are finding the additional one. And this additional one next work with here, and then they will take the hydrogen alcohol, and they will also leave this group. See, another one, unequally. Formation of primary alcohols using organometallics. Page number 479. Please visit, especially everywhere I didn't mention the page number. Where I mentioned, it means that I want you to check it out for examples or details. So here we have another one. If you have aldehyde, formaldehyde, Greek night reagent, it will form primary alcohol. And if you have here is a alkyl group, so you may think that it can be like secondary, tertiary, like that. Even if you have more branching ketone, it can even further can be continue the reaction and can produce the acid even. So reaction of a Grignard with formaldehyde will produce a primary alcohol after protonation. That's the most important things I want to say, that in the book you will see couple of examples, specific couple of examples. Here only formaldehyde, but in the book you will find more. So try to practice there. Please visit there when you review there. Yeah. And I'm looking for a book. I got one book for the general chemistry, and I will keep the book here. Then I think if anybody needs any help, any officer, I can also help from the book because I follow books. Synthesis of secondary alcohol. As I said, see here, it's common sense. If you first see that this is formaldehyde H, so it will make primary alcohol. It is aldehyde. If you have the alkyl, another, it will make the secondary. If you have the another alkyl, it will make the tertiary alcohol. Like that. It's a common sense. Once you once you learn, once you read it, it's not so tough. Just couple of reaction like we talk in the alkane alkene, and that similar things we have, as I say, mentioned the pace. Those are couple of things I would suggest you to practice. Other than that, just you need to focus and spend some time. And this is not easy. This is the, as I said, the most advanced and final organic chemistry for the undergraduate student. Obviously, there are so many organic, but this course is the most advanced for the undergraduate. So you need to spend some time here. Here we have some that show how you would synthesize the following alcohol from the compound containing not more than 5 carbon atom. So you can see here this kind of, so this is a tertiary alcohol if you look into this one. And we have also this bond. So this is actually, you know, how the question will become. Sometimes, as I mentioned before, that sometimes we are giving, we are giving you this one, we are giving you this part, we are asking you here, or we are giving you this two part, even the product, we are asking you here, or 3 number, we are giving you all and we are just asking you the product. And this product is actually this is the product, but they didn't ask you for the product, they ask you for the reagent. So that's why, but obviously in my case I will not give you anything that I didn't teach you, but just you need to learn is this type of, because as you know, the general polar chemistry, but obviously everybody will follow the books. So hopefully it will be fine. And I wanted to publish your short quizzes, but since the final examination will be general poll, so I'm little also studying the test bank. We have most of the professors follow it, the test bank we have. So that's why I'm taking just a little time, but remember that I'm going to upload the 6 quiz, maybe this 3 chapter. We have total, I think, 11 chapter. So I will today check out that for the first examination how many chapter. So don't worry, we have exam next month. Today we are which day? Today we are September 16th. So I think we are at the very good position, and I really wish that each of my student will do great in the examination, and I will try my best to support that. Yeah. So try to practice. So what we are talking, that this kind of question, why I'm telling that it is sometimes very difficult that we are providing the supporting material for each topic, each segment. So that's why when I talk, I try to give you the hints so that you have an idea that what is going to be here. Yeah, kind of question. So this is just a Greek nut reagent reaction with the different kinds of ketone, aldehyde, the way we can produce the ethoxide, we can produce the different compound like this or alcohol. Yeah. Here we have any of these 3 syntheses would probably work, but only the third begins with fragments containing no more than 5 carbon. 1, 2, 3, 4. And there is another one. Yeah. So we guys need to check it out. Grignard Grignard reaction with acid chlorides and ester. So use 2 moles of Grignard reagent. Their product is tertiary alcohol with 2 identical alkyl groups. So when the Grignard reagent react with the acid chloride or ester, they will provide the tertiary alcohol, the product. Reaction with 1 mole of Grignard reagent produce ketone intermediate, which reacts with second mole of. That's the important things I want to tell you. So I mean, it depends on the amount of reagent. Okay, so if you have the, I think last class I also mentioned. So if you have 1 mole, that means the reaction will stop at ketone intermediate. If you have 2 mole, it will be further continue. See here, the acid chloride or ester, COOR, this is the ester group, and this is the acid COCl acid chloride group. Okay, so remember that if you have 1 mole Grignard, it will be stop at keto intermediate. But actually, for the tertiary alcohol, you need the 2 mole of you need the 2 mole of Grignard reagent. So if you have some question related to here, you need to look into the how many molecules of Grignard reagent we have. On the basis of, you need to choose the product. The organometallics attacks mechanism with this acid chloride. So actually what happened? Organometallics means actually, Grignard reagent, we have the magnesium and we have the alkyl, we have the halogen. That's why we also tell the organometallics. So organometallics, how the attack. So same things. It will go here, and as a result, this bond will be breaking, and here the R will come. Yeah, this R will come here, this R we will have, and this bond will be breaking, and in the next chapter, since the charge will be transferred here, and here will be another new bond, and this will be eliminated. That's called the expel. Yeah, expel. Somewhere you will see the word. This will be eliminated like that, ketone. And this ketone will react with the another. So remember, if you have a 1 mole of Grignard, the reaction will be stopped in this intermediate. And when you will have another extra, that means 2 mole of Grignard, then the reaction will be pursued in this second level, alkoxide intermediate and tertiary alcohol. And this reaction is not new. I think we also checked the alkene, and just few slides ago we already checked it out. This reaction is very interesting. I still remember I first learned about this Grignard reagent. This is very famous. I learned when I was at the 11th grade. I still remember, yeah. It's really, please take your notebook. Do not only practice by visually with your eye. Take your notebook, take your pen or pencil and practice. Trust me, you will be master on this organic chemistry. You need to practice. So mechanism with ester. Same kinds of mechanism, just a different the Cl and the R. Other than that, everything is same. If you look into here, everything is same. Just the group is to change, okay? Now, addition to ethylene oxide. Ethylene oxide, how it will work with the Grignard reagent. So I will go here. Let's see. Grignard and lithium reagent will attack epoxides, also called oxidants. I think we already talked. This is also in the last chapter. And open them to form alcohol. So this, you remember? Yeah, we talk in the, I think we talk in the alkene chapter is also. Alkene, not only alkene. We start with alkene. Yes, we talk in the alkene chapter. So what will happen when we are talking about both, because sorry, Grignard reagent contain magnesium, and similar another is lithium. So both reagent will eligible to attack this type of epoxide or ethylene oxide. So first they will attack and open the ring. this ring will open. They will attack here. So when they will attack here, you can see here that what is going to form. So R, when it will attack, because this bond will form, and as a result, carbon will make bond with this alkyl group. And when alkyl, and this part will join with here, because this is the negative and this one is the positive, so it will go here, see. And when we will add the water, it will be, so I mean, even the, yeah, it will be alcohol. Similar is here. This is the another one, specific one. See, this is the general rule alkyl, and this is the specific example. In the book, you will find more example. So here, CH2, and this is actually, you don't, if you see here, sometimes people do trick here. Here, how many C? Carbon is 1, here is 3. So that's why this is C4, and here is 3 hydrogen, and 3 times 2 is 6. So 3 plus 6, 9. So actually, this one and this one is the same, okay? Yeah. This reaction is favored because the ring strain present in the epoxide is relieved by the opening. This ring strain, I talked details in the last semester alkane chapter. Anyone having the alkane chapter, you guys can go back and learn, because if I want to start, it's very difficult to save, time. Okay, so anyway, we can do that. This is your main job, and if anybody interested, you can ask me. I will upload the alkane chapter here. The reaction is commonly used to extend the length of the carbon chain by 2 carbon. Okay, so this one they are telling the extend by the 2 carbon. So let's see. Here we go, 2 carbon extension, and there, yeah. Lithium dialkyl cuprate. This reagent is another reagent you need to learn, the Gilman reagent, but very famous. Grignard is very famous, but still we need to learn. So we will learn here today the 3 different reagent: Grignard reagent, Grignard lithium reagent, and also here is a Gilman reagent. So what is called the Gilman reagent? This is the Gilman reagent: copper, lithium, and alkyl. So dialkyl cuprates, the name is dialkyl cuprates. So when it reacts with alkyl halide, they form this type of, it seems the alkane, correct? This is alkane because I can see the single bond. Yeah. So how they will do? They will take one R and this R, and also the 1R with the copper, and this lithium go with this halogen. This is how they will make it. And then again, they can react with copper iodide. I see. So then they make this R2Cu. This is called the Gilman reagent. So that means the Gilman reagent can form by the reaction of these two, and this is our Gilman reagent, and they can react with this type of alkyl halide, form the alkane, copper alkane, and lithium halide. Remember and practice. Limitations of organometallics. Organometallics means the Grignard reagent and organolithiums. They are very good nucleophiles, but if the acidic proton, that means proton comes from acid or acid nature compounds, then they start to work as a strong base. So when they work as a strong base in the presence of multiple bonds with a strong electronegative at 11, the organometallics will act as nucleophile. However, sometimes they here the limitation that they work as a strong base in the presence of acidic proton, and that sometimes interfere their regular properties. continue the limitation, how they work as a strong base. So this is somehow proton. If we see the acidic proton or these are proton, so then they are pK. See, it's changing. You have here some specific example. So this is this reagents limitations. So if you have this kind of question, just to make sure. Now the reduction of carbonyl. This is also another very interesting and famous reaction. I think you know that oxidation means the gain of oxygen and reduction means the gain of hydrogen in the product, correct? So when hydride reagent add to hydride ion, reducing the carbonyl carbon, we already know, correct? Carbonyl carbon, kind of these kind of things. So when we add the hydride ion, reducing the carbonyl group to an alkoxide ion with no additional carbon atom. Sorry, protonation gives the alcohol, reduction of aldehyde. See here, you need to remember here, then you can solve lots of examples. So reduction of aldehyde, when you will see the CHO group, this is CHO aldehyde group. So they will yield, primary alcohol. And when you will see keto group, they will give you the secondary alcohol. So this is called the complex hydride. Sodium borohydride. I think we also little talk into the last chapter. Lithium aluminum hydride. So this is complex hydride because they do not have a simple hydride structure like that. Okay, so they are then complex hydride. This is the boron. So the bonding of the metal makes the hydrides more nucleophilic and less basic. Okay, this is the purpose we use this type of hydride reagent. So you need to learn lots of reagent, correct? You don't need to be memorized, but at the same time, I have seen the question comes. Maybe you may have idea when you are doing the homework. I will also do little bit of check the homework, what type of question, and overall, I have already selected my question. So I always try to be keep some format, similar format. So that's why I want to use little more time this weekend, and then I will publish your things. You will have a time 7 to 10 days for each chapter. NaBH4 is a source of hydride. Hydride attacks the carbonyl carbon, forming an alkoxide. So actually, if we see the example, that makes more sense. Let's see. Hydride ion, this one. When you will have a ketone, alkoxide ion, and alcohol. But I think we have to look into here, not here. See, aldehyde, primary alcohol, and if you have a ketone, secondary alcohol. Let's see. Yeah, see, this is the secondary alcohol. So you need to look into here that what type of reagent you have. You have a keto or you have a aldehyde, that you need to look into. Those type of things you need to learn. Examples of NaBH4 reduction. I'm again telling that just remember the reduction means the product will be add of hydrogen. Oxidation means the product will be add of oxygen. I mean, try to be learn easily because it's not possible that we are always go through the previous semester and learn. So this is the little things you can always remember with you that helps you for done your job. So this is a just reduction. So in the presence of the reducing this kind of agent, and they will do the reduction like that. So OH, see here this bond break comes make a bond with hydrogen, and also here is a carbon. Another this is kind of, I think, Markovnikov. Yeah, you will see. Yeah, you will see some Markovnikov style. I saw today when I was studying. Oh, I was checking the book. So yeah, so yeah, but you have the similar kinds of things here. So the hydrogen will add here and the OH. So you will find, see, as I said, remember I told you the acidity of cyclohexanol and phenol. Here we have the more hydrogen and more alkyl group. So we don't, yeah. So that's why this is less acidic than the phenol, because here we cannot, here we don't have the double bond, so we cannot delocalize or relocate the negative oxygen charge. But in case of phenol, we can do that, and this is the reason the acidity of phenol is higher than the cyclohexyl alcohol or methanol or something like that. And this is the another, yeah. So this is for the cyclo, this is for the regular one. It will, here will be OH and here will be H. See here. Lithium aluminum hydride. This is also very famous or common use in the laboratory. Lithium aluminum hydride. Stronger reducing agent for the reduction reaction. They are dangerous to work. Yes, when you will work in the laboratory, I think you have lab very careful, okay? This type of things are very corrosive. So very careful when you do. So stronger reducing agent than sodium borohydride, dangerous to work with, reduces ketone and aldehyde into corresponding alcohol. That means if you have a secondary ketone, you will find the secondary alcohol. If you have a tertiary ketone, you will find the tertiary alcohol. If you have a secondary aldehyde, you will get the secondary alcohol like that. Even if you have a it can convert the ester and carboxylic acid to alcohol. So that means it is when I was a student, I look into here the reagent, because it's very simple to understand and remember. So we know that this is the reducing agent. So what type of reaction they can do? So reduction means the addition of hydrogen. So then we note it down that, oh, this reaction they can do. Then practice the reaction. This is the way to study, smart study, not the 24/7 study. So lithium aluminum hydride, this is very common. I hope you guys will work, but be careful when you work with that. So see, they are going to add the hydrogen, OH, and then the hydrogen. Actually, you have here, yeah. So you will find. So look into the reaction, okay? Yeah. Here we have NaBH4 can reduce aldehyde ketone, but not ester. But lithium aluminum hydride is very stronger, even can reduce the ester. So this is the difference between the two reagents. So if you have kind of reaction that the ester and we give the some ester in the this side like that, we have arrow here and we have alcohol here. So we ask you the reagent. So if we give the star, what type of reducing agent? You need to put the correct answer lithium, because you see here we learned that NaBH4 cannot do that. So that's the point, interesting point you need to remember. Now comparison. So see the comparison here. So here there will be, go to work the keto group. NaBH4 and lithium aluminum hydride. If you see here, they cannot do that, but they can do alcohol. They stop here as a ethoxide or intermediate, but they can do in presence of here. Catalytic hydrogenation. Catalytic hydrogenation. Hydrogenation means add of hydrogen, addition of hydrogen. This is we know. We already, this is third time I think we are discussing. We discussed during the in the end of alkane chapter. We discuss in the alkene chapter. We discuss in the alkyne chapter, and we again discussing. Yeah, this is very common and popular. So maybe yeah. So what we do, we know that we have the palladium or palladium or platinum. Hydrogen will be adsorbed here, and then the hydrogen will add here. Break the bond and add here. The reaction is not commonly used because it will also reduce the double bond and triple bond that may be present in the molecule. Okay, so they reduce the size of double bond. Oh, I didn't want this. How I got it? Close it. Oh, no, no. What happened? Oh, sorry. I'm not as, I mean, I'm doing this site for the lecture. This is the first semester. But the last 8 years, I frequently use the Blackboard and how to say Zoom. Zoom I start when the COVID-19 comes. I start, but I'm very familiar with the Blackboard, and here I'm learning also. So you may see that I don't want to go too much things because I'm learning. I think that next semester I will also be very expert on that. Anyway, selective reduction. Hydride reagents are more selective, so they are used for frequently for carbonyl reduction. Okay, so no, I need to talk here. This is 1, 2, but alcohol is here. So 1, 1, 2. See, 3, 4, 5. Yeah, you guys need to practice the name. So 2,2-dimethyl pent 4-enol. You remember we talked because here the double bond is start, so we need to mention. So they can do the reduction, and they will do the reduction will always be here carbonyl. So here will be H, and here will be H, and the bond will be breakdown. So we will find here like that. This is one, and also we can also do here this one. I think that's all. We have last thiol. Yeah, this is I think our last topic. We didn't have that actually 10.5 something, the commercially available alcohol. So I delete those part. You don't have in the syllabus. Other than that, all you have in the syllabus, all the topic that you have in the book. So sorry, sometimes if I cannot, I mean, if it is lengthy, this is not my, I don't want the personally, not like that. Remember that I just need to do my job to full the syllabus. As you know, the general poll question, other professor teaching question involve here. Sulfur analogs of alcohols are called thiol. Thiol is actually this group, okay? This is called the, I mean, sulfur analog of alcohol are called the thiol group, and aces group is called the mercapto group also, yes. And named by adding suffix thiol to the alkane name. Okay, let's move. Thiols are more acidic than alcohols. Why? Let's see the pKa value. This is called the thiol. So if you have the ethanol pKa value and thiol pKa value, you can get it down the Y. So here we have some the phenyl, and they can react with the alcohol, and they will take this hydrogen, go here, and they will leave at a negative ion here, and this is water. So this is a reversible reaction. Reversible reaction means they are not so stable. So we can come back to our original situation again. For comparison, ethanol. Oh yeah, we have see the pK ethanol. pK 15.9 means K will be opposite value. So yeah. So pK is less means the more acidic. You can see here. Here the ethoxide. This is the thiolate, we say thiolate because of the sulfur. So that means the oxygen actually replaced by the sulfur because of the thiol group. So if this is oxygen alcohol, it will form ethoxide. That means if this oxygen is replaced by the S thiol, they will just replace the thiol. So that means this is the same as we did the ethoxide, but just a replacement of sulfur by sulfur takes place of oxygen. This is how you need to study. Synthesis of thiol, alkyl halide plus sodium hydrosulfide. Actually, you can also write like that, but we actually write normally like that so that you guys can understand that what type of reaction is going. This is the electronegative, have the lone pair, they can available donate, so they can make a bond here. Essays are this, they will make, yeah, they will couple here. And sodium halide, yes, sodium halide is here. This is commonly made by the substitution 2 reaction. We have, after this chapter, we have lots of alkyl chapter and particular reaction. In the next chapter, we will be discussing. Thiols are commonly made by SN2 reaction, so primary alkyl halide work better. To prevent a second alkylation, use a large excess of sodium hydrosulfide with the alkyl halide. So that means you can prevent the further alkylation if you use the excess amount of reagent. Okay, done it. And you know, this type of things, this is how it established. So they do research, improve, and the reason is that what you need. So this is how the, and future lots of upgradation of this kind of reaction will be happen. We will see, obviously. Thiol oxidation, as I said, oxidation means addition of oxygen, reduction means addition of hydrogen. Who help to do oxygen, oxidizing agent, who helps to do reduce, called the reducing agent. Okay, so here you could see that this is the compound we can do oxidize and we can make the bisulfite compound. Still, if we add this and we can reduce and come back to this compound. Okay, so thiols can be oxidized to form disulfide. The disulfide bond can be reduced back to the thiols with a reducing agent. So this is the thiol oxidation example. And that was all for the alcohol chapter. And I don't want to do any more today. We have studied a lot actually. It seems no, but it's a lot of you need to practice. And these 3 chapters, I am going to, in the end of the week, I'm going to publish your short quizzes. If I feel that I need to give you some support materials for the practice, I will give you. Especially the name I will give you. Sometimes name helps you, but your chapter is basically, your syllabus is basically the chemical reaction part. So focus on that. So I don't want to upload anything that kind make you the confused that oh, the Dr. Ara is giving, that means she can make a question. No, our focus mainly the syllabus. But sometimes if you look back into the homework and if you feel that lots of, I'm not sure, I saw one day but I did not see the all the questions for the 3 chapters. I saw the alkene, so I saw that some names, some mechanism, they are asking some reagent, they are asking some product, lots of example. That's why I'm telling that look into the books or try to do the example. Yeah, and if you have now any question, you guys can ask me. And I know that if you have, oh, by the way, any student having need the accommodations, disability facilities, uh, email me. I will set your exam and quiz with the extended time. Like I got for the one student, I will do for that. Yeah, I keep her email, her or his email as a pin email. So when I will do the quiz, I will give she or he will get the automatically extended time. Though I give the lots of time because 5 questions. Normally, if you study maximum 15 minutes, 20 minutes, but I normally give 35 to 40 minutes. But still, this is your right. If you have added advantage need you officially and you need those medical issues, we are here to help you. So if you have a question, ask me. If you don't have, I want to finish because I have one more class right now. Yeah.
How many attempts we have for the one quiz?
I'll give you a lot. I think last semester I asked the Dr. Bound and Dr. Bound tell me the 4 or 5. So I need to just recheck the last semester question and I will give you. Don't worry, don't worry. I want you that you guys all pass with the nice grade.
Okay.
Yeah. I try to make question on the basis of lecture presentation.
Okay.
And I follow book. So all are same, correct? I follow book, the
Mm-hmm.
syllabus, yeah. Yeah.
Professor, are all
Yes.
those short quizzes going to be on Canvas still, like last semester?
Yes, ma'am. Yes, honey. On campus. Same. And I will do that. Don't worry. Yeah, I will do that.
Thank you.
Yeah. You're welcome, honey. Oh, yeah. So that's all. If you don't have, I want to finish here. I need to run now. So have a great day, and I'm happy that this time I able to finish the 3 chapters within. Though I'm little late, I'm not sure I'm too late because we have the login and we check it out that other professors are almost same places. So yeah, have a great time. Yeah.